While all molecules exhibit London dispersion forces, only polar molecules exhibit dipole-dipole intermolecular forces, or attractions. Polar molecules are molecules that have a permanent uneven distribution of electrons. And this is a review from Chapter 3, where we were first introduced to polar molecules. So molecules that are polar have what's known as a permanent dipole. A dipole is a separation of charges, and that's why this is called a dipole-dipole interaction. So let's look at a graphic of a polar molecule. HCl is a polar molecule. Chlorine has a much higher electronegativity than hydrogen, and in this molecule there's a permanent separation of charge where chlorine has a partial negative and hydrogen has a partial positive. And this partial negative on one hydrogen chloride molecule is going to be attracted to the partial positive of another hydrogen chloride molecule. So any molecule that is polar will exhibit a dipole-dipole intermolecular force. Here's another example of a polar molecule. This is dimethyl ether, and oxygen is highly electronegative, and even though there are two nonpolar parts, alkyl groups are not polar, the high electronegativity of the oxygen makes this a polar molecule. So the oxygen has the partial negative charge, while the two methyl groups have a partial positive. So the partial negative of one molecule is attracted to the partial positive of another molecule. So this dipole-dipole attraction is generally much stronger than the London dispersion force, which are just instantaneous dipoles. Dipole-dipole is based on permanent dipole and only happens when a molecule is polar.